building of the second Van Brienoord Bridge. In 1965, when the first Van Brienoord Bridge was commissioned, some 29,000 vehicles daily passed this 6-lane river crossing. 10 years later, this number had already tripled, and the capacity of the existing bridge had become inadequate to cope with all traffic. To effect a better traffic circulation, a change in the existing situation had become necessary. Various possibilities were discussed. An underground river crossing, a widening of the existing bridge, or a new bridge beside it. In the decision to opt for the latter alternative, the prevention of traffic disruption during the building activities played a major part, together with traffic technical and aesthetic aspects. Traffic delays would largely be avoided if the new bridge were to be constructed somewhere else and floated into place as a complete unit. By making a highly attractive and technically interesting offer, the Zwijndrecht company Groottint was awarded the order to build the arch bridge in Zwijndrecht and assemble it beside the existing assembly hall. In November 1987, Groottint started building the second Van Brienoord Bridge. The two main girders for the roadway and the main girder connections, the carriers, were made by Groottint's associated company of Pen and Bowdown in Dordrecht. The rectangular box girders were welded together to a length of 60 meters and internally preserved before being taken to the assembly halls in Zwijndrecht. Meanwhile, 198 floor slabs were assembled in Groottint's gigantic assembly hall. These floor plates, stiffened with U-shaped sections, were made into 18 roadway sections. After the welding of the carriers, the roadway sections were transported to the construction hall. Here, the main girder segments and roadway sections were welded together into a span of 60 meters long and 27 meters wide, weighing 550 tons. In a specially built preservation hall, the bridge road sections were blasted and painted before being carried to the construction site by multi-wheel trailers. Here, the 5 road sections were placed on the supports and connected. The arch edges, wind braces, and K-frames, manufactured elsewhere, were constructed into arch sections by Groottint. After a trial assembly, the arch segments, weighing over 120 tons, were transported across the factory site to the final assembly site parallel to the Drecht harbor. The positioning of the 5 arch segments could then be started. With the assistance of 2 enormous floating derricks, the tack lifts 1 and 7, the first segment was taken to the origins of the bridge. Joining the segment to the origins was a precision job, in which maximum cooperation between man and machine was absolutely necessary. While the derricks held the arch segment in place, the two ends were connected by means of mounting bolts. The bolt connections between the arch segments had been pre-drilled during manufacture. During assembly, the holes were reamed 2 more millimeters to meet small adjustments in the building process. The arch supports, which had been placed on the roadway for the time being, also contained provisions to enable adjustments in the interconnection of the arch segments to be carried out. These supports were also used in the jacking up of the finished segments to create more room for the final segments. For this purpose, the ends were provided with a special auxiliary construction. The 2 derricks slowly lowered the closing segment of the arch into the widened arch opening, so it could exactly be put in position by means of the auxiliary construction. By placing the already fitted segments into the starting position, the last connection could be made. 5 days after the start of this complicated operation, the last arch segment had been connected and the bridge was ready in its full length. To enable the 11-centimeter thick cables to be mounted, the roadway was jacked up some 400 millimeters in the middle of the bridge, so that the cables could be fitted stress-free. As to the cable connections, it was required that the cables be interchangeable in a relatively simple way. For this purpose, an anchoring system was chosen for the new bridge, in which the cables could be tightened by means of a drawing jack, after which the nuts were fitted to the cable heads. As soon as all cables had been fixed and the anchoring nuts tightened to the correct theoretical positions, the pile-supported roadway could be lowered. At this point, the bridge was only supported at its ends, while the roadway was suspended from the cables in the arch. After measuring the individual cable strengths and checking the shape of the bridge, the procedure to sail the bridge into place was started. From the building site, the bridge was moved over the water, supported by vertical jacks moving on skids. By means of a hydraulic pulling system, the skids were pulled in a horizontal direction along steel skidways reaching over the water. After all arrangements had been made, 2 pontoons of 100 by 300 meters were moored under the bridge. To guarantee a correct position of the pontoons under the bridge and later ensure a correct balance between pontoons and bridge, vertical guide rails were installed after the positioning of the pontoons. The purpose of this was to make jacking up and checked transfer of load possible at a later stage. After ballast water had been pumped out, the bridge could then be lifted from its supports and anchored to the pontoons. Four tugs and 2 push tugs led both pontoons and their 5,000-ton cargo to its final destination. During transport, ballast water was taken on to create sufficient space for passing the Spijkenisse Bridge. This unique transport attracted a lot of media and public attention. During this passage, the pontoons had nearly 60 centimeters clearance, while the bridge ends were almost trailing through the water. Clearance between the 45-meter-high arch of the new Brienoord Bridge and the underside of the Spijkenisse Bridge was about 30 centimeters. The super transport continued its way along the Nieuwe Maas to the Koninginne Bridge and the railway bridge. Although there was more clearance here, this part of the transport was no less spectacular because passage took place at night. The pontoons were moored in the direct vicinity of the first Brienoord Bridge, and ballast water was pumped out. The bridge was also jacked up 2.5 meters to enable sailing in between the piers. As soon as the bridge had been maneuvered between the piers, a heavy vertical guide construction was mounted on each pier. At the the same time, the cables of the pre-constructed jacking system on the piers were connected to the bridge, after which the bridge was jacked up 18 meters. As soon as the bridge had reached the required passage height of 25 meters, skid beams were fixed under the bridge. Once the piers have been finished, the bridge can be moved along these skid beams and placed in its final bearings. Towards the end of 1992, when the complete reconstruction of the two Van Brienoord bridges is finished, one of the most notorious causes of traffic congestion should belong to the past. A fine piece of work by Dutch bridge builders, to which Groot Tint of Zwijndrecht in particular has contributed a major share.